Welcome to part 2 of our 3-part installment on arrays and processing. In this lesson, we'll introduce the processing software package. Processing, which was originally built on top of the Java language, was created to help those working in the visual arts learn to code. So we'll be using this ability to visualize data and interact with, say, our keyboard and our mouse to control our Arduino this semester. To install processing, head over to processing.org. And on the left navigation menu, click on Download. Based on your operating system, download and install Processing. With the software package installed, go ahead and open up Processing. And you'll notice that the Processing IDE looks eerily similar to the Arduino IDE. This is because Arduino was actually based on processing. Some things to notice here, you'll notice only a run and a stop button. And what we'll find is that the IDE for processing is actually checking for compile time errors in real time. So they'll be popping up as we start typing here. And this black console here at the bottom, this will be useful for debugging and printing information to the screen. So let's jump into some code here. Let's start with a simple hello world program. Similar to the Arduino IDE, we'll type in our void setup function. And you'll notice already in real time, it's telling me, hey, you're missing the right curly bracket. So it's debugging in real time here. So let's go ahead and close that bracket, close that function. And let's do a simple print line here. We'll go ahead and print line hello world. With that complete, go ahead and run the program. And we see in our console at the bottom here, a single hello world. So just like the Arduino IDE in our setup function here, it's only going to run that one time. So you'll see a single hello world. As I mentioned, processing is focused on visualizations and visualizing data. So instead of a loop function like in the Arduino IDE, we have a draw function. So we'll type void draw. Once again, you'll notice checking for errors in real time. So we'll go ahead and close that with our right curly brace. And now if I put the print line hello world in my loop function, it will go ahead and print that over and over and over again to my console window. Now let's draw something in a window. But first, let's go back to processing.org and take a look at the processing language reference page by clicking on Reference in the navigation bar. Similar to the Arduino language reference page, you'll find a wealth of information about all of the commands and functions that are associated with processing. The first thing we'll do is initialize the window using the size command. So scroll down and on your left under Environment, let's take a look at the size command. And if I scroll down under the size command reference page, we'll see the syntax here. So if I'm going to call the size command, I need to input a width and height of my window. Returning to my processing window, let's go ahead and initialize a window of size 100 by 100. First thing I'll do then is erase my print line call for hello world. And in my setup function, let's go ahead and initialize a size of 100 by 100. Let's now set the background color of my window. So if we go back to the processing language reference page, under color, let's click on background. And you'll notice the background function here requires an input of an RGB value. That's a red, green, blue value, and those are 8-bit numbers. So it's going to be a number between 0 and 255. In processing, I'll add a background call here, and I'll assign the numbers 255, 0, and 0. So max on red, 0 on green, and 0 on blue. So an RGB 000 would be black, and 255, 255, 255 would be white. And when I run the program, I end up with a 100 by 100 red window. I'm going to add something to my window, and to do that, I'm going to need to account for 2 additional functions under the color section here on the reference page. I'm going to need to account for fill. That'll be a fill color of the object that I'm drawing. And you'll notice that the fill requires an RGB number as well as its input. I'm also going to need to account for the stroke or the outline of the thing or the object that I'm going to add to my window. And the stroke also requires an RGB input. So let's go ahead and enter our fill and stroke. And here I'm using a fill of 255, 255, 0. That'll be max red and max green. That'll end up with yellow. And I'll go ahead and set the stroke or the outline to yellow as well. I've decided I would like to draw a circle on top of my 100 by 100 red background. So if I head back to the language reference page, let's click on ellipse. And I'll notice that ellipse requires 4 inputs. And in fact, these are 4 floats that need to be defined for my ellipse. I'll have an A and B, an X and Y coordinate of the center of the ellipse, and a C and D, which would be the width and height of my ellipse. Of course, if I wanted to draw a circle, these would be equal. In processing then, let's add a call to ellipse. And you'll notice as soon as I start typing here, the real-time checking for errors is telling me that ellipse is expecting 4 floats, right? And we saw that on the language reference page. So let's give ellipse 4 float values. Here I have 50 and 50. That'll be 1/2 of the XY coordinates of my 100 by 100 background. So that'll be right in the middle of my square. And 30 by 30, that's going to be the diameter of my circle. Now let's go ahead and run that. And here we have it. Here is our 100 by 100 red background square. And we've drawn a yellow circle on top of that square with a yellow fill and yellow stroke. And you'll notice the center of the circle is, looks to be about halfway across my square here, which is great. And the diameter here looks to be about 1/3 of the 100 height and width of my square. Let's now animate our circle by continuously increasing its diameter. To do that, let's declare a variable here that I call circle size, and let's initialize that equal to 0. In my draw command, I want to continually increase the circle diameter. I want to animate the circle diameter. So this value of 3030 is going to be changing, and we're going to set that equal to circle size. There are a variety of approaches to continually increase the diameter for our animation. I've gone ahead and used 2 if loops here. So the first loop says if circle size less than 51. This implies I'd like to plot my circle from diameter of 0 up to a diameter of 50. If that condition is true, circle size will be equal to circle size plus 1. So I'll increment the diameter of my circle. And the second loop is checking for the case where circle size is equal to 50. If that's the case, we go ahead and reinitialize circle size equal to 0, such that when we go through the loop, our circle diameter starts at 0 and increments upwards to 50 again. One other important item of note is that our stroke, or the outline now, needs to be plotted in something like black, anything other than yellow. If we left it at 255, 255, 0, we wouldn't actually see the diameter increasing. So here I'll use black. And when I run the program, I see my 100 by 100 red background. It's a square. And I see my circle size with the diameter continually increasing now. So I'm in this draw loop, and I'm just continually increasing this variable circle size that's defining the diameter of my circle, and that's continually incrementing, which is continually increasing the diameter of my now animated circle. I can clean up this animation just a bit further by wiping out everything on the screen each time a circle is drawn. To do that, I call a background function here, 25500, and each time I run through my draw loop now, I'll wipe everything off the screen and then plot my circle of increasing diameter as denoted by the variable circle size. In terms of debugging your code, should any problems arise, I recommend using print lines in the same vein that we were using them with the Arduino IDE. So if I put a print line here and the argument is circle size, this should print the circle size variable, or the diameter of my circle, as it's animated on the screen. Let's run that. And sure enough, we see our animation with the circle continually increasing in diameter, and in the console at the bottom here, we see that variable printed to the screen. Now, instead of continually increasing the diameter of a circle, let's take a circle and translate it across the screen. To accomplish this task, I'm going to define another variable here, another integer that I call circle x, and that'll describe the x coordinate of the center of the circle on my screen. I'll also modify my code in my draw function here such that the circle will translate across the screen. So here I have ellipse. Now I'm going to draw the center of the ellipse, the x coordinate at the circle x variable location. I'll leave the y coordinate at 50. I've reduced the size of my circle diameter down to 5 by 5, so we can see it translate across the screen. And now I'm going to adjust my for loops as well. So the first one will look, is the circle x coordinate less than 91? Because I'd like to translate from 0 over to 90, so it doesn't run off the screen effectively. If so, I'll go ahead and increment my circle x position by 10. And in the case where circle x equals 90, let's reinitialize circle x equal to 0, such that the circle goes back to the left hand or the beginning portion of the screen. I run the program, and I see my circle racing across the screen. Now that's a bit fast, so let's slow that down. Let's add a delay of 500 milliseconds or half a second and rerun the program. Now I see my circle translating across the screen at a more comfortable pace, let's say. So this is an advantageous way of displaying data. You might imagine replacing the circle and the red background with the screen of, say, an oscilloscope that you draw in processing, and the circle represents the oscilloscope signal translating across the screen. We can accomplish this rather easily, in fact, by moving our background call within our draw function into the second if loop. Now, only in the case where circle x is equal to 90, i.e. we've drawn circles across the screen up to the coordinate of 90, only in that case will we reset or flash the background. Let's take a look. And now we see, much like an oscilloscope, our circle is translating across the screen, and when it gets to the right side of the screen, the coordinate circle x equals 90, we reset the screen and start back from the left. And finally, we can replace our y coordinate of the ellipse of 50 with our variable circle x as well, and we'll see our circle translate in 2 dimensions now. And interesting to note, the circle is translating from the top left corner of the square background to the bottom right corner, and that's because in processing, as with image processing techniques, 0, 0 is the upper left-hand corner in terms of the coordinate system of the image.